The only remaining model in the Add Trend Line window that we will discuss will be the exponential model. Before we look at the exponential model, let's look at how we would set up the exponential model as given in the Add Trend Line window. The logarithmic model took the log of the independent variable and used it to predict the dependent variable. The power model used the log of the independent variable to predict the log of the dependent variable. The exponential model uses the actual value of the independent variable to predict the natural log of the dependent variable. So let's begin by putting here the natural log of U5 mort, and ln is often used to designate natural log, and in fact the function for Excel is ln of the number. So this is the natural log of 320. Now I'll click this all the way down, and the first step in our solution is to go to Tools, Data Analysis, Regression. Now the dependent variable is the natural log of under 5 mortality, which is already indicated. The independent variable is the actual value of GNP, and that also is indicated. We have labels in the first row, and the output range will be F1 right here. So when I say OK, I get this result. Now this says that the value of U5 mort natural log can be predicted by using GNP, multiplying it times the coefficient for GNP and adding the coefficient for the intercept. That will predict values in this range, that is approximately 5, 4, and so on. But we want to predict U5 mort. So I'm going to insert a column here, and I'm going to make this U5 mort. Again, P for predicted, it could be hat. Now, the first thing that we're going to do is we're going to take the intercept coefficient and we're going to raise the value of the natural log to the power of this intercept. Right here I'm going to put the value of the natural log. It is approximately 2.718282. And here I'm going to say that the 2.71282 is being raised to this power, and I get 99.82. Now to reproduce the predicted value for under 5 mortality, the first thing I'm going to do is say that under 5 mortality for Niger is equal to this value times E being the value of the natural log, which is right here, raised to the power of the coefficient on GNP times this value for X, or this value for the predictor variable. Now in order for this to work properly, I need to put parentheses around H18 times B2, because otherwise the power would be taken before the multiplication would be done. Now I'm going to fix H19, H20, and H18 with F4s, and when I hit enter and format this as a number, I see that the predicted value for Niger for under 5 mortality is 95. If I click this all the way down, I get the predicted value for every country. Now let's look at how this appears in a chart. We'll go to the chart wizard, XY scatter, and finish. And we'll clear that. And now we see that when we use GNP to predict the value of under 5 mortality, when we have used the natural log of under 5 mortality as the dependent variable in the regression, and the formula as given here, we get this pink line of predicted values. Now let's right-click the data series, go to Add Trend Line, select Exponential, and on the options sheet, display equation on the chart, display R² on the chart, and when we enter, we get two things. We get the projected line for the exponential model, which goes right through the pink points that we predicted using the regression analysis. And we get the equation for the exponential model. And you can see that the 99.821 is the same as this value here, which is the value of E, 2.718282, raised to the coefficient of the intercept. We also have this value of minus 0.0002, which is the coefficient for GNP. And we are accounting for 41% of the variance here and 41% of the variance here. So, if you select the exponential model in the Add Trend Line window, what you are essentially doing is asking Excel to give you the result of a regression of the natural log of the dependent variable on the actual value of the independent variable.